Okay, so here we go. Now I'm going to share my desktop with you. So here's my desktop. Let me close this guy, close this guy, close this guy. And what I'm going to do here is show you the homepage for the course. So chances are you're in the morning section if you're attending at this time. However, you can Zoom at any section you want. So let me go back one more. So here, let's see, dashboard. That's what I want to go to. Okay, so this is my dashboard, and you can see I have 4 classes in my dashboard. Chem 1A, Chem 1A, orientation letters, and CR Keep Teaching. You want to link to your Chem 1A class, whichever that is. And you'll notice that this opens up to what we call the home page. At the top of the home page, there are announcements, and usually it just shows the most recent 5 announcements, and then that's it. And you can scroll and find the other announcements if you wish. And as you scroll down, you can see that we have module 0, which is the introduction module, which is stuff that you should have done by now. Okay. There's the overview for the module, which basically will show you all the things or list all the things you need to do for that module. And some of these things are, pretty short. Okay, so I'm going to go back. And the idea is that I'm going to start every module with a module overview. So you have a list of things that you need to do. The list is basically what you see in the module. Does that make any sense? Mm-hmm. So it's redundant. Some people like that. That's why it's there. If you don't need it, fine, don't use it. So here's my welcome to Chem 1A letter. It tells you basically you're going to be studying at least 17 hours a week. That's the big take home there. Here we have the orientation letter and we have the syllabus. So these are all kind of in order. They will only be in this module. So if you need to refer to those, you need to know that you need to go back to module 0. The introduction to online learning video is basically a video you're supposed to watch to get you to understand that this is not a course that should be taken lightly. It's like any other course. You're going to learn stuff every day. Proctorial. Here I give you the Proctorial support link so that you can load up Proctorial on your laptop. You need to load it up on the Chrome browser. It will not work on any other browser. It has to be the Chrome browser. And we have 2 quizzes here. The first quiz is to get you in the mode of knowing what you are allowed to do during an exam. So let me get this out of the way. During an exam, you're not allowed to open new tabs. You're not allowed to open windows. You're not allowed to go any place on the internet. You're only allowed to look at the exam, and that is it. If you do any special keystrokes to make things bigger or smaller, it might very well kick you out of the exam. So this is the opportunity for you to find out what things you can get away with and what things you can't get away with. And you want to avoid those things that you can't get away with during an exam. You can take that quiz as many times as you want. I will keep the best grade. The second part is how you will actually submit your answers for an exam. You might be asking, well, if I'm taking an exam and I have to show my work, how can I do it if I can't open up a window? Well, the answer is you take the exam, you write down all your work. When you're finished, you will then close the first exam. You'll take photos of all your work. You'll upload it to your computer, put it in a nice file. And for the second quiz, you'll upload those one at a time in the appropriate spot. And since you're not opening the second quiz until after you've taken the photos, sent them to your computer, put them in a nice folder, You'll have them all ready and at hand to be able to pick and choose and put the proper problem in the proper answer, I should say, image in the proper answer. And you'll only be given 15 minutes to do that. The idea there is you're not supposed to close your first window when you're done with the exam, sit around and work on it, and then submit it later. You're supposed to submit it within 15 minutes of finishing the first exam. Do you understand what's going on there? So the first exam, it's very tight so that you're not allowed any outside sources. The second exam, you only have 15 minutes, so it doesn't matter whether you have outside sources or not. You're going to be spending your time uploading files that I will grade. Okay, so you want to practice that. You want to make sure that you have a nice phone that you can take pictures of everything, send it to your computer, upload them. Also, I would suggest you open each image and resave it as a PDF. It's a lot easier to upload to the computer without any problems. Go ahead, Alice.
So in playing with this yesterday, I was finding that I was taking a picture and using Chem. It's a new program for me, Chem Scanner. And the way to send those to your computer is a web browser that you have to take a picture of the web browser, and you get that little box screen that your phone recognizes that and sends it to that web browser. But I was having problems with Proctorio letting me use another browser for giving you those files.
For quiz
for quiz 2.
Okay, yeah. Well, I'll have to set up another quiz 2 to make sure that doesn't happen. Okay. So that we can make sure.
Because I was even speaking with a Proctorio person who was saying you can't, from these settings, go to another browser. And I didn't know if it was just that both Chrome and that scanner program are both new to my computer and I don't know them.
I may have screwed up the settings. So okay, we'll just give it another try. The idea there is that we want to make sure that before you take the first quiz, which is next Friday, actually next Friday doesn't matter. Quizzes are locked down. You don't get to use any information on the quiz. You only get to use, you don't get to use any information on the quiz, so it doesn't really matter. I just need to make sure that I have this practice quiz up and running by the time you take your first exam, which will be in about 3 to 4 weeks.
Great.
So we'll make sure you have more practice. And it's worth 0 points. I actually had the submit as part of the first quiz, but I realized I had it locked down and there's no way you could submit anything. Hopefully you've already submitted to Student Intro. If you look at Module 1, you'll see that we have the links. I'll probably have to update this document. I have the overview. And then I have lectures here. I'm going to go ahead and open up 3C Media lectures. And with these 3C Media lectures, you can see that you can choose to watch whatever lecture you want. I believe at the bottom, if you scroll down, you can watch 1, 2, or 3. And let's see, how long is this sucker? 50 minutes. Moving in constant random motion. So now I refuse to watch these because I made them. But the problem with that is I don't know what's on them. They move in a straight line till they hit something, then they bounce off and move in a straight line. Now I'm going to back up. Something else. So the randomness. Okay, so I'm going to back up even more conceptually.
Are those 3 different versions though of almost the same thing?
No, those are 3 different lectures.
Okay, good.
Now,
because I watched the first, but not the next 2. So
yeah, if you go to YouTube, it's the same videos, but on YouTube. Now, when I go to YouTube, you see what happens? I use Firefox as a browser. Yeah. It says no, Tony. So when I open the site in the new window, wow, YouTube is slow today. You can see that I have all 3 videos here, and there's 1, 2, and 3 over here. So we're starting to watch that one that was 53 minutes long. All of these videos are about an hour long. So you can watch it in YouTube or you can watch it in 3C. The reason I have both is that last semester, it was easier to load them up to YouTube and get them out there immediately. 3C Media is where I have them captioned and they're legal, so to speak. Now, all that matters for the state is that I have legal videos captioned. If I have additional videos like in YouTube and people want to use them, that's fine, as long as I have those 3C Media videos. Okay, so you're free to use whichever ones you like better. Also,
I was using, sorry.
I should say, you might also be able to go to the YouTube site and go through the playlists and so forth.
Yeah, I was finding a broken link and having trouble accessing the YouTube on Chrome. So, and then I didn't see the web link anywhere that I could click on it. So, but I'll just search it next time if that's the way I want to go.
I hate Chrome. I only use it for the exams. So I'm a Firefox user myself. Okay, so all of these links should work. So here's the second lecture. And you get to see my ugly mug at the beginning. Okay, so you're being recorded. So, and I usually start with, okay. So you can hear that a lot. Okay. All right, let me go back here now. Now, some people don't want to watch all these videos, or maybe you want a preview of the particular chapter. So here I have these PowerPoint presentations. These PowerPoint presentations are long. Now, if you're worried that you don't have PowerPoint and you can't watch these, you actually have access to something called Office 365. It's free. I did not like it at first, but probably because I'm an idiot, I did not know that you can actually download Office 365 onto your laptop or your computer screen or your computer itself. I was going through the internet to connect to it all the time. And I thought, this is the stupidest thing in the world. So this is a nice overview provided by the textbook publishers. I have not read through these because I hate PowerPoint. Okay. So I'm going to back that up. Okay, so as we scroll down here, you'll see that in this same part with lectures and homework, I have the homework, and the homework is worth 0 points, but it's also worth all the points. What I mean by that is if you can't do the homework, you will fail the exam. That's all there is to it. So here are 10 problems which I've written out. And in addition, number 11 is try to do as many end of chapter problems as possible. And I would start with the ones that have answers in the back of the book. That way you're a little bit satisfied with that you got the correct answer or not. Also, I would say this about the book is that in the book, there are these example problems that are worked out in the chapter. And you should read through those example problems. And if you think you understand how to do the example, you should then cover up the book solution and see if you can do it yourself. If you can't do it yourself, you didn't understand the example. And when I say do it yourself, I mean to, I guess I can say the word literally here, literally write out the solution. I think that's the first time I ever used literally correctly. If you can't literally write out the solution, then you cannot pass the exam. And a lot of people think they know how they would approach the problem, how to solve it, and this is what I would do. But unless you actually do it, you're not going to do as well. It's kind of like driving a car. You can read about it all day long, but until you actually get in there and start pushing on pedals, find out how fast the car goes, how quickly it stops, you know, what kind of pressure you need on the pedals, you're not going to be a good driver. And some of us are never good drivers. But the way to get good at chemistry is to do it by writing out things. Okay, so that's the homework. And for the first few chapters, I actually have homework solutions. You can see here, this is the homework solutions for module 1. And I would avoid looking at this until you try the problems. I need to change the title. This used to be module 2, but I decided I wanted to make the module names the same as the chapter names. So before, my module 1 was intro, module 2 is chapter 1. So you can see what I'm showing you here. And the importance of this is that this is the kind of work I'm going to expect you to show me on an exam. If you take a look here where it says, what is the density of the sample of iron pyrite? You can see that I give you the formula for calculating density. I put in numerical values, plus I put in the unit. In this case, the unit on top is the gram. The unit on bottom is centimeters and it's cubed. But this is basically the kind of work I expect to see. Okay, so that's the importance of looking at the homework. Wow, look at that. I did a great job of making that. I didn't do that for the rest of the semester because I didn't have time. So this is the kind of work that I expect to see. Okay, now let's go back. And we're going to get to the lab stuff because today, Tuesdays and Thursdays, the focus is on lab. So now we're going to focus on lab. So let's talk first about the lab notebook. Your lab notebook must be bound. So I'm not sure how well you can see what I'm showing you here in the screen. I picked this up at the dollar store. Let me think. So it's got a binding. When you open it up, all the pages are bound together. This is an example of a lab notebook I would not use because it's not lined. And when I don't have lines, I draw at all sorts of weird angles. This I picked up at the same dollar store. You can see it says composition notebook. It's bound. And it's actually lined. It's got pages that are lined. And I'm going to go ahead and show you the first thing you want to do for your lab notebook is on the very front page, you're going to write table of contents. So can you see where it says table of contents? And can you see the one in the upper right-hand corner? And then what I'm going to do is I'm going to flip this open. Now, if this is page 1, what is the backside? Page 2. So that means this is page 3. I'm not going to bother writing down the 2. I'm just going to write down the 3. A lot of books do this because it's a waste of time to write a number on every page. And you should number every page in your lab notebook as soon as you get it. And you should do it in pen, not pencil. You never write in a lab notebook in pencil. So you number every other page. And the idea here is the lab notebook is a record of what you've done. It's like when you type a paper to be turned in, you never type it in pencil because the lead would break when the key struck. So let me show you examples of lab notebooks that are not okay. This is what I call a spiral bound notebook. This is not allowed, period. This is a loose leaf paper. I went to the dollar store and got all these things this morning. You can see the 3-ring binder. This is not allowed. So anything that is not bound is not allowed. No ifs, ands, or buts. Okay. And let's see. I had another lab notebook. Let me show you a lab notebook that I had from my time years ago. So you can have a lab notebook like this. This one, when I bought it, the pages are already numbered. You can see I have a table of contents in here. You can see I have lots of red marks because I was not a good student. All of this is written in pencil because when I took chemistry, pens weren't invented yet. So we used pencil. That's a joke. You feel like you're getting taller? Because I'm pulling your leg. So, and you'll notice that with my lab notebook, I've got this whole section here with things crossed out. You see that? You never cross out things in a lab notebook. Okay, so where are you going to find out all of that information about your lab notebook? It's here in lab notebook requirements. So we're going to go over that quickly. You can read it in more detail later. Okay, so blah, 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 must be bound. Entries, pages must be numbered. On the front of your lab notebook, I always tell my students to write your name, College of the Redwoods, chemistry. And the reason for that is this class is normally a face-to-face class. And as soon as we can do it, it's going back to face-to-face. It does not work online well at all. But the reason to put all that stuff on your lab notebook is if you happen to leave it somewhere, they can get it to College of the Redwoods. College of the Redwoods can get it to me, and then I can get it to you. Okay. The first page is table of contents, write in permanent ink. You'll notice here it says if a mistake is made, draw a line through the mistake. And I give you an example of misspelling mistake. So you put a line through it. You never erase anything from your lab notebook. Now, for those of you who might be a little particular about everything being perfectly neat, the mindset you need is that this is neat. Erasures are not neat in a lab notebook. Erasures are like scribbles all over the place. They're horrible. Pages torn out. Make your lab notebook look like what's something just awful? Like a dog turd. I think that's awful. So ripped out pages, whiteout. Whiteout is like a cat turd. You never do any of that in your lab notebook. A beautiful lab notebook will have things crossed out all over the place. And that looks beautiful. That looks like a pristine dog chasing a Frisbee or a tennis ball. Just enjoy, you know? That's when you see a cross out. That's perfect. Okay. Required sections, you want to have a title, introduction, safety. Now, I'm going to go through these very quickly. For the introduction, you want to give the background for the lab. And on Thursday, I'm going to be talking about the measurements lab, which will be posted by then. And we'll talk about what you would write in the introduction. Now, for the lab notebook, I think that these sections, you just want to make them simple. I like bullet points. That's how I like to organize things in my mind and on paper. Safety, you always list the safety issues. For measurements, we're going to be using water. We're going to be using a note card, a ruler. There are no safety issues. So what you do when there are no safety issues, you write, there are no significant safety issues related to this experiment. But you always deal with safety because the number one issue with lab is lab safety. And speaking of lab safety, you want to make sure you have a pair of goggles when we get down the road to doing some of the labs that are more dangerous. And you notice this one doesn't have any holes in the sides. They're also not the glasses that you put over glasses. They're real goggles. You can get these at Ace Hardware, Pearson's, any hardware store. You get them at Harbor Freight. They're not very expensive. The procedure is what you write out for what you actually did. Now, a lot of times people will have the procedure written out on a piece of scrap paper. And when you're actually doing the lab, you find out that you deviate a little bit from that. And so to avoid crossing that stuff out for those people that are very particular, what you can do is you can have the procedure on a piece of scrap paper, but then when you're actually doing the lab, you can actually write out the procedure in the lab notebook as you're doing it. So your first bullet might be, I measured the length and width of an index card in centimeters. That would be your procedure. Okay. You want a data section. And for the data section, you list all the data you collect, plus you label it. You don't want a number hanging out there that says 7.0 centimeters and no one knows what it refers to. So it might be the length of the index card, 7.0 centimeters. Okay. Sometimes the data collected is repetitive, so you make a table. You want a calculation section. So if you're doing any calculations, you put example calculations. If you do 10 calculations that are similar, you're just multiplying two numbers and you're getting centimeters squared, you would just show one example calculation. So you might be asking, so if I do those 10 calculations and I only show one, where do I put the results of the other? And the answer is in your results section. And then lastly, you should have a discussion. And this is an example of a horrible, horrible discussion. The lab went well. That's just horrible. This one is kind of refers to a density type lab. And so I give you some examples of what you might have here. If you have any mistakes or things that happened in the lab that were unexpected, you would try to address the reasons for that unexpected result. A lot of times people will do a lab and nothing goes right. And that doesn't mean it's a bad lab. It's only a bad lab if you don't learn from your mistakes and then try to correct them. Are you with me there? There are some labs I'm going to have you do where you're going to get the wrong answer. And I do that on purpose. The idea there is you have to get comfortable being wrong. Because in science, you're wrong more than you are right. We don't have a journals where we publish all the things that didn't work. But if we did have a journal where we published all the things that didn't work, the body of scientific knowledge would be amplified tenfold. And it's not bad to learn from mistakes because usually you don't learn from success. And by the way, these little sayings that I give you, if you ever want to put them on a t-shirt and you start selling them, I just want 10% of the net, not the gross, just 10% of the net. So you don't learn from your successes, you learn from your failures. Great t-shirt. I don't know, have you guys ever done that where you've done something and it just worked perfectly, like maybe even a recipe? Wow, that was great. First time. Next time you're like, geez, it's not the same. And that's where you really learn what works. Okay. All right, so that's what you're going to have for each lab that we write about. Since we're doing up over 20 labs, you want to be able to go through and do this quickly and not have to spend a lot of time on it. So that's another reason that's great, that you don't have to erase things. You can just cross it out and write the new material. It's such a time saver. Plus, as it turns out that, you know, some people, when they start collecting data and they go, this can't be right, and they erase it, and then they go on and they find out that, oh, it was right. They've just erased a lot of good information. So it's better to have it there where you can see it and just a big old cross through it or a line through it. And you can always reuse it if you need to. Any questions here about the lab notebook? So your first lab assignment, your first lab notebook lab you're going to put in there is the one we're going to do on Thursday, which is measurements. I'll be posting that later today. Okay, so there are these 5 videos that you can watch instead of Netflixing. So you can instead of Netflix and chill, you can lab safety and chill. I'm not sure what that means, but there you go. And then there's a lab safety quiz. Let me go there. You need to finish this by tomorrow. And the first thing I want you to notice is this says answer questions 1 through 31. So let's go to the link here. So the link, actually, I've got to preview this to get to the link. So here's the safety quiz. There's 120 questions. Which ones do you answer? 1 through 31. That's it. So here, let's see how we take this. So here we go. Introduction. Which of the following describes some key elements of an appropriate safety training program? And you collect. So I'm going to, without reading the answers, I'm going to select all of the above, because usually when you see that, you know that's the answer. Okay, and let's see what happens here when I do this. Pollution prevention, I'm just going to pick B. Oh. Actually, you can go back and do number 1. Oh, and look at that. I got that one wrong. I already did 2, I think. But you can go through and do these one at a time. And eventually you can get to the point where you've done the first 31 and you do the score quiz. And you'll notice that for this, in the introduction, I tried 3, I got 1 correct, and I got a 14.2%. I didn't try any from I tried 1 from section 1 and I got none of them right. But you can see that the introduction and section 1 add up to 31 questions. So you need to do those 2 parts, the intro and section 1. And what I want to see is a 7 tried, 7 correct, 24 tried, 24 correct, 100%, 100%. And you will take this screen, take a screenshot and submit it. And that way I know that you have passed the safety portion of the quiz that's important for this class. Is that clear? And you have until tomorrow to do that. So don't dilly-dally. What's nice about this is you saw that when I did a problem and I got the wrong answer, it told me it was the wrong answer. It does not tell you the correct answer. So you can go back and figure it out with a little bit of thinking. Fair enough? Okay, so let's get out of this lab safety quiz. And I have set this up. Let's see, I'm going to go to edit here. I'm allowing multiple attempts, and the quiz score to keep is the latest. And you can see your responses. Now, when this lets you see your responses, it just lets you see that you submitted an image, that's all. Okay. And you have until the 20th to get it done at 11:59. All right. So let's go back to okay, so here you can see that I've got the materials agreement and liability waiver. These are still works in progress. I plan on having those printed today. Basically, you're going to sign online the waiver and sign online acceptance of the lab kit. And I'm going to make it like a little quiz where it says, I accept responsibility, blah, 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 blah. And you're also going to upload your address so that I can send you the lab kit. You won't need to come to campus. But that also means that you'll be returning the lab kit, because we're going to loan you not only chemicals that you'll be using and you can't return, but we'll also be loaning you equipment that you can use and should return. We'll want those things back. So these two forms are basically need to be signed if you want the lab kit, and if you want a chance at passing the class. If you don't want to sign the waiver and you don't want to assign a responsibility for the lab materials, you won't get a lab kit. You won't be able to do some labs, and I'll drop you from the course. In my syllabus, it basically tells you if you miss 3 or more labs, I may drop you from the course. Okay.
How far in advance are you mailing the lab kits that we'll need? Because I don't get my mail quickly.
Well, we're hoping to mail it tomorrow because everyone should submit their answers today. And until we get the addresses, we won't be able to mail them. So if we mail them tomorrow and you are nearby, you should be able to get it by Friday or Monday, I would imagine.
And we need to be using them the next Tuesday, Thursday. Is that the idea?
The things
we'll
in
be
the
using
lab
them next week.
You might need next Thursday. But for Thursday's lab of this week and Tuesday's lab of next week, you should be able to do those using the things I told you to buy: the balance, the ruler, the graduated cylinder. Okay. You need those 3 things for Tuesday, or for Thursday of this week and Tuesday of next week. So the lab kit should get to you by Thursday of the following week, which is when you'll need it. But even if you don't get it then, since the lab won't be due until the following week, you still have time to get the kit and do the materials or do the work. Okay. So later today, I'll be posting the measurements lab also for Tuesday. And if I don't get it posted today, I'll have it posted tomorrow before Thursday. Density is what we'll be doing next Tuesday. And then there are these parts here. The module 1 discussion is basically something where you need to post questions or comments, and you need to reply. And you need to do that twice for each module. They don't need to be real lengthy things or anything like that. It might be something along the lines of, I attended the Zoom session and I learned what's supposed to be in a lab notebook. I'm glad I was there. See, that would be the pitch to get more people to come to these things. I don't know if you guys read this, but last semester, 3 people attended Zoom sessions regularly out of 44. All 3 passed. What I didn't tell people was how many didn't pass of the remaining. I can tell you that I think 6 of them passed.
Wow.
So Zooming helps a lot. I don't know if it was the fact that they weren't Zooming or they just weren't ready for an online environment. This is a tough environment. Chem 1A is not made for this. You can see that the rest of the modules, they are not published. There is stuff in here. Maybe I can show it to you, but I haven't published it.
Do you happen to have an outline of the whole class, like just the basics, the chapters, or are all the modules in line with the chapters so that I have a preparation ahead of time?
They're all in line. If you want to write this down, we're doing chapters 1 through 10 and chapter 23.
1 through 10 and 23.
And here's the order we're going to be doing them in. So you might want to write this down too. Are you ready?
Yeah.
We'll do chapter 1, and then 2, and then 3.
Check.
Until we get to chapter 10. And then we're going to skip all the way
Get
to
to 23. Great.
I don't skip
That's
around.
easy.
I don't skip around in the book to make it a lot easier for the students to know where I'm going to be.
Okay.
It's not always the best thing because sometimes the teacher wants to teach things in clumps where you grab stuff from different parts of the book. But just to make life easier on all the students, I do it in the order of which you see it in the book. Fair enough? So
Yeah.
I'm not saying it's a better way. I'm just saying it's my way. Okay?
Okay.
And then you can see I'm a smart ass too.
Yeah.
By what I, do you want to write this down?
No,
With one.
don't need to.
I do that a lot just because
Yeah.
I find these times pretty darn boring. Okay, do you have any questions?
I guess I have a few questions. So for
Now,
the
Did you say your name's Sagan or Sagan?
Sagan,
Sagan. Okay, Sagan.
yeah.
Go for it.
So for the ConferZoom sessions, we have 3 sessions today. Is that sort of 3 of the same sessions, or is that all?
Yeah.
Okay, so we just
there
attend.
are 2 sections of class. One section normally meets from about 10 to 11:15 on Monday, Wednesday, Friday, and 10 to 1 o'clock on Tuesdays and Thursdays for lab. So what I've done is I've scheduled 5 meetings at that 10 o'clock slot when you would normally have to be here.
Mhm.
And we will cover lecture material on Monday, Wednesday, and Friday, lab material on Tuesday and Thursday. And the way lecture Zoom sessions are set up are that you're supposed to have watched the videos and you're going to come with questions. So maybe you tried homework problem number 2, you've seen my solution, but you just don't understand it.
Mm.
And so you asked me to do that, and I will do that for you on a piece of paper. I have a camera where I can show you what I'm writing, and I will explain how I came to that particular conclusion. If you have problems from in the text, like example problems where you don't understand why they're doing things the way they do,
Mhm.
I would be glad to show that to you. And also from the end of the chapter problems. If you have problems you've tried but you don't understand, I will do those for you. If you come to the session and you don't have any questions, but you want to be the wallflower, kind of seeing what's going on, what I will do is I will take questions out of the back of the book and I will show you how I approach them.
Mm.
And what I normally will be doing with those is I'll be doing the problems that don't have answers in the back of the book, so you wouldn't know what the answers are anyways. And I'll show you how I approach reading the problem, figuring out what they're asking, and then deciding what to write out as the answer. And the utility of that is that's what I expect on the test. Does that make any sense?
Yeah, so
you don't even need to come prepared to ask anything. I will show you stuff if you don't have any questions.
right.
And I will do that
So-
for an hour and 15 minutes.
Just to recap, each of the 3 times the 10
let
to
me-
11. Yeah,
Let me
could you-
round back to that.
Yeah, recap.
So the
real
afternoon
quick.
section is normally from 1 to 4:30 or 1:15 to 4:30. So there are 5 lectures that go from 1:15 to 2:30 for the afternoon class. Now, since you don't really have an afternoon or a morning time really anymore, you can come to any sessions you want. So if you
Okay.
missed the morning 11 o'clock session or 10 o'clock session, and you can make it to the 1:15, by all means. Now, for those people that are decided that they want to work all day and they might be free in the evening, I made the 6 o'clock session. It's
Mm.
abbreviated. It will not be a full hour and 15 minutes. It's only going to be an hour, 6 to 7. And that's for my own sanity, because basically I'm going to be going at this from 10 until 7,
Right.
which is a good 9-hour spot. And in between classes, I'm going to be doing grading, publishing new modules, so forth and so on. I will have more than enough to keep me busy.
Okay.
So, if you miss any of those, you can attend then also. And the plan was to, since I have so much variability of when you can watch, I didn't really plan on recording any of these sessions. although I have recorded this first one.
Hmm.
So,
Okay, I think,
and here, I'm not sure, can you see where it says, oh, this is module 3. Right here where it says module 1 Q&A. This is where I would normally post the recordings from these sessions.
hmm,
I really am disappointed that, I'm really glad that you two showed up. I'm really disappointed that 20 other students didn't. And I've read some of the student introductions, which make me think that half the students will not finish this class. Because I read the student introductions and people say, oh, I like to study by reading things over and over again until I get it. And maybe a geology class where it's a lot of definitions. Yeah. Chemistry class, physics class, biology class. No, not going to work. You got to do math class. Can you
Definitely.
imagine trying to read a calculus book? I read the calculus book until I get it. You'll never get it. Chemistry's like that.
So I do often like to show up to study sessions and hear other people's struggles, because sometimes the first time I go over a problem, I think I've got it, it's no problem, and then I add in the stress of a test and I'm in a different body chemistry and it's not quite so easy. And so if I have heard other people's struggles, I often feel like I've gained a new perspective of how to approach problems and interactions.
Right.
I'm hopeful that if you do have beneficial Zoom conferences and they're recorded, that those get posted, because those will be the most helpful for me to look at. I'll speak up for all the people who are trying to figure out schedules. I can't speak for all of them really, but I do know it's definitely a challenge to figure out how to time manage in a completely different way. It's
Yeah.
easier to block out a schedule and be there with you. And I'm a pretty good student. Being in a space where I'm multitasking everything else is a lot more challenging.
Yeah. Well, one of the things I tell people about chemistry is that you got to treat it just like everything else that's important in your life. Family,
Yep.
working, eating. It's something you do every day. You don't ignore your family 4 days a week and then just tend to them on weekends. You can't do that with
Right.
chemistry. My son
Well,
tells me that
I
the
would,
only
but
thing I've
it's
ever,
hard. It's harder.
yeah,
It's harder really attending when you do have the family walking in the middle, you know?
it
So
is, but it's better than not attending and trying to do it later.
absolutely. Absolutely.
This
I
one
don't see
thing
how
that
that's
my,
possible.
the only thing my son says, the one piece of advice I've given him that was good was that it's easier to keep up than it is to try to catch up.
Definitely.
If you find yourself in a place in chemistry where you're trying to catch up, you should be anxious. You should be really anxious because it doesn't work in chemistry.
Yeah.
It works in econ. I know that because I did that in econ. It doesn't work in chemistry. Not at all. It's just because it's the type of animal. I'm teaching you about chemistry. I'm going to use the language of chemistry to teach you about chemistry. And that makes it even more daunting. It's like trying to learn Japanese and they teach the class in Japanese. Our Spanish teacher does that. She teaches you Spanish and she speaks Spanish at you from the get-go, no English. So you're trying to learn Spanish when you don't speak any Spanish and you're just being taught in Spanish. It's just so confusing, but it works. And that's the way I teach you chemistry. I teach you chemistry using the language of chemistry. Now you have taken chemistry before. That's one of the prerequisites. So you do have a leg up. You do know what's going on, but depending on your previous instruction, this may be have more depth or it may have less. Some high school teachers really go all out and some are more laid back because they're the PE coach or something teaching chemistry. So I hope you had a hard teacher because that always helps. All right. So the other thing I'm going to say, let's see, I've forgotten your name. It's Sagan.
Yeah.
Okay, so Sagan, after the evening sessions, there's only going to be 2 of them. I just refuse to work Friday night at 6 to 7.
That's fair.
And basically, I take the weekends off. This weekend, I spent a lot of time replying to people, but normally on weekends, I'm not here. I'm not here for the students. I'm not teaching. I'm not grading. I'm going to try to make this as much as I can a 10 to 7 job, 5 days a week, which gives me about a 40-hour week.
All right.
And that's it. So with that being said, we have another 15 minutes, and normally I would start doing problems. So are you ready?
Sure.
Okay, so what I'm
Yes.
going to do here is I'm going to flip this guy back around. This thing you saw earlier. This is my camera, so I can share with you what I'm going to write on paper. So let me do that now. Okay. So here you can see the paper that I'm going to write on. You can see that I'm left-handed. So what that means is that I will write something and you can't see it because my left hand covers it. This is a hard copy of the textbook we'll be using. You probably won't have the instructor's edition. Honestly, I don't know what the instructor's edition has that you don't have. I don't think it has anything extra. You will probably have a digital copy of this. I have a digital copy myself that I don't use because I'm old and I like books better. Let's see now. So we'll be going through here's kind of the table of contents. We'll be going through chapter 1, 2, all the way through 10, gases and their properties. And then we're going to jump to chapter 23, which is about carbon. In Chem 1B, they basically cover the other chapters. In chapter 1, we talk about chemistry and its methods. In the previous books by this author, chapter 1 was actually chapters 1 and 2. They were combined together here. Okay, so here, if I flip through to chapter 1, you can see it has an outline of the sections. And this is how I normally like to study. I don't read the chapter. I find the chapter to be very boring. And I don't know what's important. So I don't know what to take home from it, but I look at the pictures because I like comic books. And so I'll look at these pictures and try and figure out what's going on. So here they're talking about mixtures. Here they're talking about elements. Here they're talking about compounds. And then physical properties. Extensive and intensive. Extensive depends on the amount present, like mass. Mass depends on how much is present. And so it goes on and on. And then finally, we get to the end of the chapter. And we have these problems here. So you want to practice trying some of these problems. So for instance, let's look at number 2 here. State whether the following is a hypothesis, theory, or law of science. Global climate change is occurring because of human generated carbon dioxide and explain. Okay, so what's your initial take on this? Global climate change is occurring because of human generated carbon dioxide. Do you think it's a hypothesis? Do you think it's a theory? Or do you think it's a law of science?
I might argue
Mostly
that it'd
theory.
be a hypothesis because it doesn't, because a theory would be sort of tack more onto,
Tested.
yeah, it sort of explain, well, it does sort of explain. I think hypothesis sort of explores a reason for that phenomena, and then theory actually has tested stuff to support it. But I might have to.
Okay, so it sounds like we're unsure.
Yeah.
So here, guess what I'm doing?
Reading.
I'm finding the section where it says hypotheses, laws, and theories. And now I'm going to read because I'm looking for something. I call this active reading. Novels, you should not do this. Novels, you read from front to back and you kind of enjoy them. Textbooks, you figure out what's important and what's not important, often by looking at the problems at the end of the text. And based on their questions, it tells you, oh, this is what you want to think about. So here we can see that this says, hypothesis, a tentative explanation or prediction in accord with current knowledge. Okay. And then here we have a law, concise verbal or mathematical statement of behavior that always seems to be the same under the same conditions. So there are laws that are very important in chemistry, like the law of the conservation of matter. We found out that matter cannot be created or destroyed. So if you start off with 10 pounds of stuff, you'll end up with 10 pounds of stuff. And here we have theory. Oops, I'm sorry. On the next page, a well-tested unifying principle that explains a body of facts and the laws based on them, and is capable of suggesting new hypotheses to be tested experimentally. Now, based on what I know about climate change, to me, climate change is more of a theory because it does unify a lot of principles. It's been well studied, and you could argue that, well, it hasn't been proven, but theories aren't necessarily proven. Theories are just bodies of facts that are, when interpreted, lead you to an idea of an explanation for why something is occurring. This is why they call it the theory of evolution. No one has ever seen anything evolve, but that theory of evolution embodies a whole lot of different facts and experiments that have been done. And it seems like the best explanation for how organisms have changed over time. It's kind of like the idea of Occam's razor, where usually the simplest explanation is the best. And the idea that it was ancient space aliens is kind of stupid, because that's not the simplest explanation. That's your default. Well, if we can't figure out what the hell's going on, it's ancient space aliens.
Well, it's pretty simple.
What's that?
It's pretty simple.
No, because how did they get here? Why did they not leave a record? There's nothing simple about it whatsoever. And well, if they were really there, why didn't they just tell us?
Story versus evidential.
Yeah.
Based
so
information.
The History Channel is great when it does history. It's horrible when it does ancient space aliens.
Yeah.
I love the History Channel. I think there's a show on the History Channel called Pawn Stars. I learned more history from that than I learned from ancient aliens. Plus, it's got fun characters on it.
Yeah.
Okay.
Human history.
Yeah, history is cool stuff. I never appreciated it when I was in college, but I do appreciate it now. Okay, so you can see that we pretty much answered that. Oh, I'm going to chapter
Okay.
2.
What would a hypothesis look like? Because I mean, I understand that climate change is a theory, but when we first start out, say it was first sort of put forward, it would start out as a hypothesis. And that sounds like something like the wording there made it sound like that's something to be pursued sort of further or to be tested. Because they're saying, I think, climate change is a result of carbon dioxide. I think that's what it said.
Yes.
Um,
Well, not just carbon dioxide, man-made carbon dioxide.
right.
So climate change, without reading more into this, climate change occurs, period. There's
Right.
no doubt about that. Anyone who argues that climate change doesn't occur, you should walk away from them because they're just insane. Climate change occurs. So what are the causes of climate change? And the answer is, well, a lot of different things. It can be a result of the sun and how much sun is absorbed by the earth. That's definitely one of them. It could be due to a volcanism. So if you have a lot of volcanoes erupting, a lot of cloud cover, that could cause climate change. It's the rotation of the earth and how close we are to the sun and how far away we are from the sun. And that's climate change on a yearly basis. But over long stretches of geological time, what causes climate change? That's another type of question. So climate change occurs. That's a given. We know it occurs on a yearly basis because we have seasons. But we also know it occurs on a geological scale because of studies that have been done. So then you start coming up with ideas of what causes the climate change. Is it that, I don't know, let me think of something that you might want to test. The volcanism one. So how would you test to see whether volcanism causes climate change over a geological time? And you might try to look for evidence of volcanism and somehow date that using some sort of radio dating and find out when the earth was undergoing a lot of volcanoes erupting. And then you can do core samples and so forth and so on to find out, well, just how warm was the climate or how cold was the climate during those times. You might say, well, the hypothesis might be that, well, when volcanoes are blowing up, it's going to be hot because volcanoes are hot. And so you test that. You can do different things to find out what the temperature was at that particular time. You can do that by sea level changes and so forth and so on. And you can do investigations. And you might find out for that hypothesis that, well, during high levels of volcanism, the sea levels actually retreated. So there was less water in the sea, which means naturally that you have more water captured as snow. So things are colder, right? So you just tested your hypothesis and found out, well, that doesn't seem to be right. So something like that would be a hypothesis. But when you start building a large body of evidence and it collectively seems to indicate something, that would be a theory. Now, as far as the climate change being caused by man, there has been, I haven't read all of the papers on it, but I believe the scientists who do study this and the overwhelmingly majority say that climate change is due to man, the more recent climate change. And I have to take them on face value there because I'm not going to read all of the evidence. I don't have time to. And I have trust in my fellow scientists. And going back to this, though, the hypothesis, usually it's a simple explanation. For observations. So you see something happening, you come up with a hypothesis. It's got to be testable. If you can't test it, it's not a hypothesis. That's why scientists don't deal with the realm of God. Oh, it's there because God made it. Well, you can't test that. So it's not scientific. I'm not saying it doesn't have merit. I'm just saying it's not science. It's got to be testable. It must also be, it can be proven to be wrong. It's called the null hypothesis. If you can't prove your hypothesis to be wrong, that is to say, if you can't come up with an experiment that would show your hypothesis is wrong, it's not a hypothesis. And these are the hallmarks of a hypothesis. Simple explanation for an observation or observations, testable, and can be proven to be wrong. Theory is a unifying body of facts, explanation for usually theory is an explanation for a body of facts, not just one observation or some observations. And these guys are mutable. So what do I mean by theories are mutable?
Changeable.
You can change them. You change them based on the evidence. You know, back when Darwin developed the theory of evolution, it has undergone so many different changes as more facts become apparent. So they're mutable. A law seems to be true no matter what. That's an oversimplification. I would say it's universal. So, Sagan, I think that for the climate theory, if we're talking about it being due to man, based on the amount of piling evidence, it's the best explanation for what's going on.
Right. I'm not denying the. I understand it's a theory. I'm not denying it. I'm just when I read that sentence or that example, it seemed like, I guess the way it was
seemed too
worded.
specific, maybe.
Or not.
Perhaps. I mean,
Let's go back and look at it,
yeah,
and then we're going to call it quits because we're already past time.
yeah, that's fair.
But we've got an interesting discussion going here, so we might as well try and give it some more time.
Would if you were to go back in time when the climate change was or is as a result of man-made carbon dioxide emissions or carbon-based emissions, if we're to go back in time and sort of see it as it was being in its hypothesis form, what would that statement, how would that statement be different from how you would state it when you know it's a theory, I guess, is what that makes any sense.
Right. This is kind of like, how does a bill become a law?
I suppose so.
There is a cartoon from when I was a kid that was about how does a bill become a law? So this is like how does a hypothesis become a theory?
Okay.
Right?
So it's sort of, there's sort of that background understanding that it is a theory and not just a.
Okay, so here's where I would tell you that I don't think it was ever a hypothesis, is that how do you test that man is causing climate change? How do you test that? You don't. It's a theory, and it's a weak theory at first. So if you think about that as a theory, a weak theory at first, how would you try to support that theory? Well, you would start doing different investigations. So first of all, you would want to find out what are the CO2 levels at different times in history. Now, since you weren't alive in the Well, I don't know how old you are. Since you weren't alive in the 19th century, I know you weren't alive in the 19th century. So that's the 1800s. You weren't
Right.
alive then. I wasn't alive then. How do you know what the CO2 levels are during that time? So then you start making hypotheses for how you might actually investigate that. So hypotheses are a lot smaller little nuggets of things that you're doing compared to the theory.
Oh, sorry, were you
So,
posing your question?
and I'll be honest with you, usually theories follow hypotheses in that people discovered that there has been climate change over the years. And then they discovered that there was rapid climate change over the last 100 years. And then they discovered that the CO2 levels were rapidly changing. So all of that happened well before any theory was adopted about it being due to man-made causes. So the idea of climate change being due to man actually came out of things that have happened over the years where people have discovered all these different changes. So I'm not sure if that's really a satisfying answer for you, but we're looking at this in hindsight
Okay.
and not foresight. So a more interesting question, Sagan, might be, well, can you think of, Tony, any sort of body of evidence or body of facts that might lead to a new theory about something? And the answer is no. I'm not that deep into any sort of research. But it's an interesting question. You know,
could I try an analogy for a hypothesis that would connect to what you're saying that might help an understanding there?
Mhm. Absolutely.
So maybe we have this theory of climate change being caused by humans, and we're looking at the different analysis, and somebody's already tested and had hypotheses of volcanism and is testing the particles in the air that caused maybe, colder climate. But then somebody else is looking at, okay, particles in the air are causing climate change, maybe. So where do we find something that captures the particles in the air that gives us some understanding of what they were at different levels? So I'm going to hypothesize that Arctic snow captures part of what's in the air as it falls every year. And there is a record of that because it falls and compresses. So my hypothesis is climate change is based on air composition. And I'm going to go test it by doing core samples of Arctic compression snow.
Right. Or actually, you're looking for evidence of climate change in the core samples, right?
Right. So your hypothesis is actually like working for evidence that works to the body of evidence that is helping mutate or evolve or adapt the theory.
Right.
Which
yeah,
the science courses I've taken have kind of been like, yeah, we proposed that hypothesis comes before theory, before law, but the reality is there's this mix of all of these going on in a way that like one doesn't beget the other. So
absolutely.
In line, it's actually more of a process interacting with lots of humans and mixes. And
yeah, absolutely. And
times.
sometimes the theories kind of seem to almost come out of nothing, like Darwin's theory of evolution, which was so dramatic to most people because it seemed to come from nowhere.
Too many, yeah.
I mean, the things that he was basing his ideas on are that life has changed over time.
But he was playing with dogs and breeding and exposures to different realms of science that made him start thinking in a way that was not collective conscience. It wasn't normative in the world at that point.
Yeah, but even he wasn't able to witness evolution.
No, only adaptations.
He made different breeds and stuff, but that's not evolution.
Yeah.
But yeah, those simple ideas did give rise to his astounding theory, which is why I say it seemed a lot of people thought it was a pretty big surprise coming out of him. Mm-hmm. All right. Well, hopefully I'll see you guys tomorrow. We'll be doing problems from the back of the text. I'll be honest with you, chapter 1 is one of the easier ones for the most part, but there's a lot of good stuff to be gleaned from this stuff. And a lot of stuff to be learned. It's a good review of what you did in your previous chemistry class. Chapter 2, when we finally get there, you're going to find out that it's got a lot more information in it and math. So we'll be getting into some of this chapter 2 stuff actually fairly shortly. All right. Thank you for attending. And I'm going to see if I can adjust my Zoom meeting so they have correct times and update those files before I get going here. All right,
All right.
Sagan, Alice,
Yes, thank you.
toodles.
See ya. Have a good day.